The Mother's Milk Bank at Austin opened in 1999 to improve the availability of a safe source of human milk to all human babies. More than 2 million ounces later, the Mother's Milk Bank at Austin is responsible for helping reducing rates of life-threatening illnesses and improving short and long-term outcomes for preterm and other medically fragile babies. Protecting milk from contamination in the milk bank means that we remove sources of bacteria from ourselves or cover up those sources. Hair, clothing, and breath are sources of bacteria and viruses that are eliminated through hair nets, rolling up of sleeves, and wearing face masks. So in preparation for working in a laboratory, we put a face mask over our nose and our mouth, making sure that the metal bar in the face mask is upward towards our eyes, and we pinch it over our nose to keep that face mask from sliding up or down. That face mask is able to keep us from spreading bacteria and viruses when we breathe, but it allows us to breathe through it. We put hair nets on to cover our hair. We're constantly shedding hair, which also contains bacteria. This way we protect the milk from being contaminated by us. Aprons also protect us from milk splashes. Skin and fingernails are sources of bacterial contamination through the shedding of skin and hair. Removing dead cells through scrubbing with antibacterial soap helps protect milk from our own germs. We start by wetting our fingernails and fingers and taking a small paddle contained in a scrubbing brush package and running that paddle from one end of our fingernails to the other, one fingernail at a time. When we're finished with one hand, we rinse under the hands-free sink and we turn to the other hand. Throw the paddle away once completed. Then we wet our arms from the elbows down through the fingertips again, and we apply 5 squirts of a Hibiclens antibacterial cleaner to the scrub brush contained within that package, and we apply that Hibiclens cleaner to our forearms. We then turn the scrub brush over and we use the brush side to scrub in small 3-inch increments from our elbows all the way around the circumference of our arm and then downward toward our fingertips. The entire process takes about 3 minutes. No need to follow deliberately 3 minutes, but to be approximate means that you've covered all of that area thoroughly and there isn't risk that we'll drop a skin cell that contains bacteria into the milk that we are working so hard to protect. Milk is carefully selected from approved donors to ensure a wide mix of antibodies and nutrition. Thawed in refrigerators overnight, it must then be laid out on individual trays, labeled by specific donor name for final thawing. A milk selection sheet must be compared with the milk being laid out to ensure that it is the correct milk and that it has no milk pumped within deferral dates, dates from which we shouldn't have that donor's milk, typically because of the use of medications or herbal products. If deferred dates are found, that milk must be brought to the attention of a pasteurization technician and not laid on the trays. Each donor's milk is laid out on trays labeled with that donor's name, even if the donor's milk requires 3 or 4 or more trays. We keep those trays labeled with the name and keep them together on the baker's rack. Flasks are prepared for milk by washing 3 times each in an industrial dishwasher programmed to heat to 180 degrees Fahrenheit. This, in effect, sterilizes the flasks. To run the dishwasher, turn it on and wait for the orange light to go out. Open the door, place a tray of 8 flasks inside, and shut the door. This starts cleaning cycle 1. When the orange light again goes out, open the door. The light will come on and steam will escape. Once the light goes out, close the door and begin cycle 2. Repeat for cycle 3. The flasks are now ready. Running the flasks in the dishwasher only 2 times fails to eradicate potential bacteria from the flask, thereby contaminating the milk and leading us to have to discard the milk rather than dispense the milk to preterm infants. Aluminum foil cut into squares is used to cover the flask opening in order to keep things from dropping into the flasks. Flask labels are made from the selection sheet. One label for each last name of donors is made for every 60 ounces of her milk. One additional label per name is made for microbiological samples. When a flask is not labeled, we end up with what we call mystery milk. This milk cannot be used for processing because we must be able to link back every ounce of milk with a specific donor. Once thawed, select a tray or trays belonging to one donor and select the number of flasks needed for that donor's volume of milk. Apply labels to the flasks so that all milk is identified. Individual milk containers need to be dried before pouring into flasks so that ink and water do not contaminate the milk. Pour into flasks without touching the flask opening and without touching the insides of milk containers. If you touch the milk container to the open flask, you risk contamination of the milk, contamination of the flask, and then pouring of the milk will contaminate that milk with bacteria. That again will lead the milk to be discarded instead of dispensed for the infants. Cover with foil lids. When all containers of one donor have been poured into the flasks, milk must be swirled to mix in the fat, protein, and carbohydrates, which have separated into layers. To do this, remove foil lids of those flasks and swirl each flask for 6 seconds. If multiple flasks line them up, even out their milk volumes, and pour one into another down the line 6 times. This will ensure that the milk components in each flask are the same. The milk components in each flask need to be the same so that we can take an accurate milk measure of the nutrients in the milk, so that we can accurately balance the fat, protein, and carbohydrates for specific pools of milk. Take one flask after homogenization, swirl for 3 seconds, and pour 1.5 ounces into a 2-ounce sample tube. Taking a sterile syringe and culture tube, withdraw 3 cc's of milk and place in the tube without touching the inside of the tube or the cap of the tube. Label the tube and the nutritional sample with the donor name, and place in the refrigerator with all flasks. Keep donor's flasks together in the refrigerator. Once all milk is poured from the individual trays, this lab is finished and cleaned. In the pasteurization lab, a pasteurization sheet listing the pools to be created and the donor milk in each one is posted near the windows. The pasteurization technician will assign you a pool, and you should take the related flasks from the refrigerator in the central lab and bring them to the pasteurization lab. Double check all names on the flasks against the pasteurization sheet until you have every one you need. Line the flasks along the table and remove foil lids. Swirl each flask for 6 seconds, then even out their volumes. Beginning at one end of the line, swirl again for 3 seconds and pour roughly a third of the volume into the next flask, never exceeding 1,600 milliliters in a flask. Pick up the second flask, swirl for 3 seconds, and pour into the third flask. Continue through all of the flasks, including pouring the last flask into the first. This is 1 round. Pour for 6 rounds. Failure to follow these procedures will lead to inaccurate nutritional composition of each flask, leading bottles of milk to differ significantly in especially fat volume. We must provide a specific fat and protein content to each preterm infant, and therefore homogenization is a critical component of the pasteurization process. Take one flask and pour a 1.5-ounce sample after mixing all of the flasks. Label it with the pool number and place in the refrigerator. Pools that will be 20, 22, 24, or research quality should be poured into 3-ounce bottles. Pools that will be outpatient will be poured into 6-ounce bottles. These bottles are sterile. Remove the white caps by twisting, being careful not to touch the insides of the bottles, and careful not to pass any of your body over the open bottle. The white cap can be tossed into the recycling bin beneath the table. Line up approximately 10 bottles of appropriate size bottles in front of the line of flasks, being sure that you can see the volume markings on the bottles. When all bottles are open, reach around but not over the bottles to pick up the first flask. Swirl this flask for 3 seconds and then pour into the first bottle to just above the 3-ounce mark or just above the 6-ounce mark as appropriate. Swirl after pouring for 3 seconds and pour into the next bottle, and so forth down the line. Failure to swirl after pouring each bottle will mean that the nutritional components in each bottle will differ, again erasing the effects that you created when you homogenized the milk in the flasks. Every bottle's nutritional information should be the same. When you have completed the pouring, reach around but not over the bottles to place the flask safely on the table. Pick up the blue tamper-evident caps and one at a time place squarely on bottle 1, pushing directly down until hearing a click. Then twist to tighten the cap until the second clicks are heard. The cap should be tight and flat. Ask the pasteurization technician to verify appropriate application if you question the cap placement. Once all caps are in place, take those bottles and place into a wire basket provided by the pasteurization technician. Line up a second round of bottles and fill them accordingly, continuing until all of your flasks are empty. Take the basket of bottles and permanent marker. Write the last 2 digits of the pool number in the center of each cap legibly for identification of pool. Place completed basket in refrigerators in central lab. Place empty flasks on the bottom of the cart. Clean area of the table and notify the pasteurization technician that you are available for another pool. Between pools, changing of the gloves is critical. We don't want to cross-contaminate the milk of one pool of milk with another pool of milk, and therefore we throw away any of the dispensable items used to pour that first pool of milk, and we send for cleaning any of the non-dispensable items used in that first pool. Pasteurized milk is ready for drying when in an ice bath it has cooled to 30 degrees Fahrenheit, or when it has been cooked in the ACE pasteurizer and is taken out. Bottles should be dried with a clean towel, being careful not to wipe off the pool number. As drying, check that each lid is tight. If questioning a lid, ask the pasteurization technician to examine. Once the bottles are dry, they are ready to be labeled. Acquire appropriate labels from the pasteurization technician and apply to caps centrally, covering the handwritten pool number as much as possible. Place the bottles in storage baskets in rows of 6. If the pool exceeds 36 bottles, take 2 baskets of the same color. Place 18 bottles in one basket and place in one layer. Place the second basket into the first and layer an additional bottles in the same manner, 3 rows of 6, doubling the rows if necessary. And remove 1 bottle for sampling. Place this sample bottle in the refrigerator. Label the baskets with pool and batch numbers. Place folded colored sheets in front of each basket. Write the remaining number of bottles on the pasteurization sheet under the appropriate pool number and place the basket in a freezer in the freezer room. Freezer locations 1 through 4 are appropriate for pasteurized milk. Place only 1 newly pasteurized pool of milk per shelf in each freezer, and do your best to separate same batches of milk into different freezers. Note the location and write on pasteurization sheet. Thank you for working at the Mother's Milk Bank at Austin, helping to save the lives of fragile infants. You are contributing to the health of the next generation, a truly compassionate act of grace.